Hey, what's up guys? Welcome back. Hopefully you had a great weekend. Hopefully everyone is safe and feeling well and doing well, your friends, your families. You guys did good last week. Last week we talked about a bunch of different things, types of numbers. We talked about perfect squares. We talked about radicals. Guys, today we're going to kind of put those things together and we're going to talk about identifying rational and irrational numbers. Now, kind of like last week, as we were putting numbers in our calculator to simplify them, we're going to be kind of doing the same thing for some of these numbers to figure out if you in fact have a rational or irrational number. Now, it's really kind of simple. You're literally just identifying whether it's rational or irrational. And the way you do that is understanding what they are. So, for example, rational numbers, guys, are numbers that can be expressed as repeating decimals, terminating decimals, fractions, integers, whole numbers, and perfect squares. All right, so they're all for you, all identified for you right here. So if it's any one of these types of numbers, you have a rational number. So what would a repeating decimal look like, and when would you get it? Guys, a repeating decimal, let's say you had a fraction, right? And you had, say, 1 over 3. Well, put that in the calculator, right? Simplify 1 over 3. Obviously, this line fraction, guys, that tells you to divide. So in the calculator, you put 1 divided by 3, you hit enter. And notice, you get a repeating decimal, 0.333333333, on and on it goes, right? That's a repeating decimal. So if you ever get a number, if you ever see a number or in the calculator, you get something that looks like that, where it's 0.33333 pretty much the whole length of the calculator, guys, that is always called a repeating decimal. And you could also write that like this, 0.3, and you could put a line above it like that. That implies that the 3 keeps going. That's what a repeating decimal looks like. So if you get a repeating decimal in your calculator, guys, the number is always rational. Then you can get a terminating decimal. Guys, that's basically a decimal that stops. For example, if you were, to divide, right? 1 divided by 2. So the fraction's 1/2, and we wanted to simplify that to turn 1/2 into a decimal. Again, guys, you go to your calculator, 1 divided by 2, you hit enter, and notice you get 0.5. Well, it stops right there at 0.5 because that is a terminating decimal, okay? 0.5. It doesn't go 0.555 forever, it just goes 0.5 and you're done. Terminate means to stop. That's what a terminating decimal is. Also, let's say you had like 1.5 is a terminating decimal, or 3.2 is a terminating decimal. So if you see any of these in the calculator and they're asking you if the number is rational or irrational, your number is rational. Any type of fraction you see, guys, 2/3, that's why 1/3 is rational, because we know it turns into a repeating decimal. Right? That's why 1/2 is rational, because it turns into a terminating decimal. Any fraction you see at all, 4/5, rational. Then, of course, we talked about integers last week, guys. Remember, integers are both positive and negative numbers. So, -3 is rational. -2 is rational. +5 is rational. +10 is rational. Okay, negative and positive numbers are all rational. Whole numbers, right? Simple. 0, 1, 2, 3, 4, and on and on and on it goes. Okay, they are all rational. And then, of course, sometimes how would you get a whole number? Well, guys, if you had the square root of, say, square root of 64, square root of 64 is 8. 8 is a whole number, that's why that would be rational. Okay, that's where you would get like maybe, a whole number in the calculator. And then, of course, perfect squares, like we just talked about here. The square root of 25, guys, is 5, right? Well, 5 is a whole number, therefore it's rational. Okay, and if you notice, let's say you forgot the square root of 100. Remember, you hit second function, x squared, so you have the radicand or the square root symbol right there. You put in 100, and you hit enter, and what'd you get? You got 10. 10 is a whole number, guys. That's why the square root of 100 is also rational. The square root of 4 is 2. 2 is a whole number. That's why the square root of 4 is rational. So if you get any of these numbers in your calculator, they're all examples of rational numbers. I know it's a lot. Here's the good news. Irrational numbers, guys, there's only really two types. Irrational numbers are numbers that are not the numbers we mentioned above. So they're not repeating decimals. They're not terminating decimals. They're not fractions. They're not integers. They're not whole numbers or perfect squares. We learned simplifying radicals last week, right? We talked about how to put this in the calculator and get the decimal. So radicals are irrational. Here's why. Whenever you get a number, let's put radical 2 in the calculator. Notice when I hit enter, notice what happens. Now, the quick term for this is a messy decimal, but you're never going to describe that on your Regents as a messy decimal. But guys, basically it's a decimal that the numbers are all mixed. 1.41421356 That is what we call irrational. Notice they're not repeating. Notice it's not terminating and it stops. It keeps going. All right, so when you ever get something that looks like that, you put the number in the calculator, 1.414213562. That is an example of an irrational number. Same thing with radical 5. Let's put that in the calculator, right? We talked about that last week. Second, x squared, you put in 5, you hit enter. This time it's 2.23 606 7977. None of these are repeating, guys. This is a crazy decimal. It goes on forever. This is what we call irrational. Last example of a radical. There's plenty more examples, obviously, but second, x squared. You put in 11. Once again, boom, notice the decimal, 3.31. This is what we call irrational. 3.31 662479. Whoops. That got a little crazy right there, guys. Sorry. 2479. All right. Anytime you get a decimal that looks like this, guys, that is always irrational. Always. And then last, anything with the pi symbol. And why is pi irrational? Well, guys, go to your calculator. Hit second. The pi button's right here. Notice you get the pi symbol. You hit enter. There you go. What's the pi number? 3.14. 3.141592 right? And it goes on. It goes more than that. It's just the calculator's not showing you more. That's irrational. Anytime you get a decimal in the calculator that looks like this, all those numbers are irrational. And why? Because they are not terminating decimals. They are not fractions. They are not integers. They are not whole numbers, and they are not perfect squares. So all I want you to do today is identify for me very quickly, is the number rational or irrational? All right, we'll look at Regents questions later on this, but for right now, let's just practice identifying, and here's how we're going to do it. Okay, guys, based on the previous page, all right, and you could look back if you need to, I just want to know if they're rational or irrational and why. Okay, for example, so the first one says 3.2. Well, we talked about that. What kind of decimal is 3.2? This is rational because it's a terminating. I definitely should have typed this out. Decimal. Simple. That's why it's rational. 3.2, guys, is a terminating decimal. We talked about that on the previous page. All right. 3 divided by 8. Well, that is also rational. And I'm going to abbreviate rational with just R. Why is it rational? Because it's a fraction. And guys, fractions are always rational. Pi. Pi is irrational. Why is pi irrational? How could you explain that? You could write out the value of pi, which is 3.14159264, which we could do, right? Because when you put it in the calculator, you get 3.14159264. 1592654, okay? But also, what could you say about that? If you had to explain that on a Regents, you can't just say messy decimal. All right, so what you would say is, you could say anything. You could say it's not a fraction, it's not a perfect square, it's not a terminating decimal, it's not a repeating decimal. Okay, you could pretty much, it's not a whole number, right? That's what let's put that. It's not a whole number. It's not a perfect square. Any one of those will work, it's fine, okay? All you need to know is that is irrational. Radical 64, is that a perfect square or is it a radical? Well, let's put it in our calculator just to make sure. Second function, x squared, put in 64. What kind of number did we get? Did we get a messy decimal? No, you got 8. Guys, 8's a whole number. Well, what do we know about whole numbers? Whole numbers are rational. So this is rational. Why is it rational? You could say because it's a perfect square. All right, that's why square root of 64 is rational, because it's a perfect square. Pi plus 4. Guys, anything with pi, no matter what, is always irrational. Not a whole number. I'm just going to use that because it's easy to write. Okay. Radical 2. Let's put it in the calculator. Is it a perfect square or not? Let's see. Second x squared, you put in 2, you hit enter. Oh, look at that decimal we got. 1.14, right? It's always good to write it out in the Regents. 1.14, 142, 3562. So this is irrational. And again, I'm abbreviating, guys, rational and irrational. Why is it irrational? Because it's not a whole number. You could say it's, in this case, I would say not a perfect, perfect square. Or you could say it's irrational because it's a radical. I mean, that would work too. Radical 11. Guys, if you put radical 11 in the calculator, you're going to get 3.31662. 479. But what do we know about messy decimals? They are always irrational. And once again, because this is not, radical 11, guys, is not a perfect square. And again, sorry for the sloppy handwriting. This is difficult to write with. -7, rational. Why is -7 rational, guys? Well, because it's an integer. Guys, -7 is an integer. Simple. And there you go, guys. All right. That is a very quick, basic intro to identifying rational and irrational numbers. All right, if you have any questions, guys, please email me. My email is in the description below. Also, please download the calculator. That is also in the description below, and have it on your computer so while you're working on this stuff, whether you're watching a lesson or just working on your homework, you can have access to the calculator if you haven't gotten one yet. It is free. Comment below on what you liked, what you didn't like. Please subscribe, like, and share, guys. And as always, please, you, your family, and your friends, please stay safe, and I will see you guys on the next video lesson.